In the coming lectures, we are going to talk about graph algorithms. And when I first met with artificial intelligence, it was quite confusing that why do we have to talk about graph algorithms? And this is why in this lecture we are going to talk about what is the connection between artificial intelligence and graph algorithms. So what is the motivation exactly? Why do we need graphs in artificial intelligence? And the answer is quite simple. Many artificial intelligence related problems can be reduced to the problem of finding a path in a given graph. So for example, if we consider games, most of the computer games rely extremely heavily on graph algorithms such as Warcraft. So for example, in Warcraft, you have a given player, and if you want to go to a given location, then you have to click that given location on the map. Under the hood, the game is going to calculate the optimal path or the shortest path between the player and the location you have just clicked. And of course, there are several approaches such as breadth first search, depth first search, dash-cross algorithm, or A-star search. We are going to talk about these approaches, and we will come to the conclusion that A-star search is an extremely powerful search algorithm, for example, for these kinds of problems. So games such as Warcraft relies extremely heavily on graph algorithms such as A-star search. Okay, then we have robotics. For example, vacuum cleaners uses graph algorithms under the hood such as A-star search or breadth first search again. So in this case, these kinds of robots construct a two-dimensional map out of the surrounding objects, and they use graph-related algorithms in order to find the shortest path in order to navigate between two locations. So again, A-star search, breadth first search, and graph-related algorithms can prove to be extremely useful. And of course, we have two-player games such as chess or tic-tac-toe. So in a two-player game, we can generate a so-called game tree. And of course, this game tree is essentially a graph. So again, we can reduce the problem to a given graph algorithm because of course, graph algorithms are working extremely fine. So we know exactly how to construct graph traversal algorithms such as depth first search or breadth first search, or how to calculate the shortest path or the spanning tree. So graph algorithms are working quite fine, and this is why it is a good approach to transform a given problem to a graph related problem. So this is why it is absolutely crucial to talk about graph algorithms. And of course, we are going to consider other advanced techniques such as meta-heuristic approaches, genetic algorithms, simulated annealing. Of course, these are the heavy artillery as far as classical artificial intelligence is concerned. Of course, with the advent of GPUs, so graphical processing units, neural networks and deep learning became so powerful that now artificial intelligence is more or less is the same as deep learning. But it is absolutely crucial that 30 or 40 years ago, artificial intelligence was a bit different. So for example, 40 years ago, artificial intelligence related approaches used, for example, graph algorithms or meta-heuristics in order to solve optimization related problems. So this is why it is absolutely crucial, in my opinion, to talk about graph algorithms and talk about meta-heuristics. In the coming lectures, we are going to talk about graph algorithms. Thanks for watching.